Geology, part 2. Now we're going to start taking a look at, oh, hi, Bones. Sorry, I forgot to introduce Bones. Bones is here. Hi, Bones. Part 2. Now we're going to start taking a look at what the Earth is actually made up of. So we've been learning about the different layers of the Earth. We've been learning about how the Earth changes and changes shape and changes what it looks like. But what is the Earth actually made up of? What are we walking around on? Different stuff like that. So let's go. All right. The Earth's crust, our lithosphere, which we've been talking about. All right. It's split up into a couple different components. Okay. The first component that you have to understand, which really protects us from the liquid hot magma that is underneath us, is called bedrock. Okay. Bedrock is a very solid, thick, strong, dense part of the Earth's lithosphere that protects the magma from burning our feet off. Okay, so it's very important. Sometimes you see bedrock exposed out into the outer portions of the Earth's crust where you can see that. If you've ever driven through the Catskill Mountains, you can see bedrock popping up out of the mountains all over the place. Okay, it's usually found underneath the soil of our Earth. So here's the bedrock down here. Okay, big chunks of Earth. As we get closer to the surface of the Earth, okay, as we go through these layers of the Earth, we find soil. Now, soil is different than just rocks. Soil actually has some organic material in it, water, air, and it's more porous, which means water can go through it a lot easier. Okay, we can grow plants in soil because of the organic material and the nutrients that we find there. Okay, you cannot grow plants in bedrock. Okay, that's impossible. But soil, just remember, soil is different than a normal rock because there's some organic stuff in it that helps things grow. All right. Now, bedrock can be broken down, and when you combine it with different materials, it can become soil. But it's a long process through weathering that breaks down rocks into sediment, which is little pieces of rock. So you can see here, we've got little pieces of rock. I like this transition here. Little pieces of rock when we're closer to the Earth's surface, and then they gradually get bigger the deeper we go down into the Earth's crust until we finally hit the bedrock, which protects us from the magma. Okay. Now, what are these rocks made up of? And this is what we're going to focus on today. Rocks are made up of minerals, okay? You need to remember this. Rocks are made of minerals, okay? Minerals, okay, make up rocks. And there's lots of different types of minerals out there. But there's only a couple minerals that actually make up most of the rocks here on Earth. There are Feldspar, Quartz, Mica, and Calcite. I'm going to show you in a minute. Now, we use minerals to help identify what type of rocks we have, okay? And there's a couple different tests that we do, okay? They're called mineral tests, and I'm going to show you some minerals here in a second, not only that are common in rocks, but also some cool ones that I like, okay? There's something called a streak test, a hardness test, whether or not these minerals react to acid, cleavage, which is how it breaks, luster, which is how shiny it is, and the color of the minerals that we're looking at, okay? So we're going to go through each one of these tests, and we're going to just take a look at a couple of different minerals here, and we'll see how it goes. All right, here we go. So minerals make up rocks. So if I ever ask you what makes up a rock, it's a mineral. Minerals make up rocks. Bones, what do minerals make up? Minerals make up rocks. Just say it over and over. Minerals make up rocks. Minerals make up rocks. Just like your bones and your blood make up you and your muscles make up you, minerals make up rocks. I've said it a million times now. Okay, here's those major minerals that I told you about. These are the main minerals that help make up a lot of the rocks here on Earth. Here's feldspar, calcite, quartz, and mica. And you can see sometimes they look very similar to each other. Calcite and quartz look very similar to each other. So there's different tests that we can use in order to identify different types of rocks. So that's what we're going to take a look at. So let's go. Okay, streak. All right. The streak color of a mineral is what color is the powder of the mineral. Okay, when you scratch it on something, I scratch it mainly on a porcelain tile, kind of like this. Where's that? There we go. There's our porcelain tile. All right. So what we're going to do in order to determine what the streak color is, and we're always going to have a chart to reference. Okay, this is not stuff that you have to memorize. You do all of these tests. We look at a chart, and then we figure out what our mineral is. So this is one of mineral that I like a lot. Let me put it over here. This is pyrite. Okay. Now pyrite, another name for pyrite is fool's gold. So this is fool's gold. And one of the ways you can tell that this is not gold is because when you go on the streak plate like this, okay, see what it did? It leaves a black streak. Okay, that's not common for real gold. So I can do this. I see the powder is coming off. That is a streak test, okay, for pyrite. And so I would look on a chart next, and I would just look at to see what color minerals have a streak color of black, and that will help narrow down what type of mineral I'm looking at. So streak is very simple. You can see here, it's a couple different streaks here. Over here, a couple different streaks here. Again, you never know what to expect. The next test we have is a hardness test. Okay, hardness is how hard something is. What can you scrape it with? Okay, it's the mineral's resistance to being scratched. Some minerals are very hard. Some minerals are very soft. Okay, some you can scratch with your thumbnail. Some you need a diamond in order to cut into it with. So the mineral, one of the softest minerals out there is this one right here. There we go. This is talc. Okay, now we can take a look at this Mohs hardness scale, and we can see talc is one of the softest minerals. I can actually cut into this with my fingernail, and I can just take my fingernail and I can start scratching this. Okay, and you can see all the scratches that I've done throughout the years. Okay, now the cool thing about talc is that it actually has a nice smell to it. Talc, this stuff right here, probably everybody has in their bathrooms at home. Okay, but it's not in this form. It's all crushed up. This is baby powder. This is baby powder. Talc is baby powder. So if you smell it, it smells like baby powder. Okay, Johnson & Johnson baby powder. That's made of talc. So this is what that really is. This is a cool type of mineral that you wouldn't know that everybody uses, or that at least most people have in their bathrooms. Talc, that's what it looks like. Okay, and this is one of the softest materials. You can see different types of hardness here. We can see that it goes from 1 being the softest, 10 being the hardest. So look at diamond. Diamond is the hardest mineral that we know about. So diamond is going to be able to cut into all of these other minerals. So calcite can cut gypsum. Fluorite, okay, fluorite, yes, that's fluoride, the stuff you find in your toothpaste, can cut all of these, okay? But if I took something like feldspar and I tried to cut topaz with it, it wouldn't work. Okay, topaz would cut the feldspar, not the other way around. So we just use a nail, okay, use a fingernail, use a penny, scratch, 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 scratch. Oh, this you'll be able to see. You can see I just scratched a couple lines right in there. Okay, and now it smells like baby powder. Nice. Okay, some other things we can do. Other ways to identify minerals, okay? Another one is its reaction to acid. So this is a piece of calcite, okay? This is calcite. And what I would do, and you'd always use supervision for this, is I would take some acid. Acid, over here. There's the camera right there. We're gonna take some acid. We just need a drop. Oh, I'm gonna do it over this, okay. Let me do it here. And I would drop on here. And if it reacts, it will start to fizz. Oh, there we go. There we go. It's fizzing. There it is. I probably shouldn't work with acid above the computer, but in the name of science. So we see that calcite reacts with acid, okay? And it had a little fizz. Now we're going to clean it up. You don't want it to damage anything. Okay, and so what would happen is it would fizz and bubble if it reacts to acid, and if it doesn't, nothing would happen. That easy. As you can see the bubbles on this mineral that they have going right here. We also have a cleavage test. That is, how does it break? Okay, how does the mineral split? And one of my favorite minerals of all time, Mica. This is Mica. Okay. All right. So what happens is with a cleavage test is that different minerals will break differently. They can break in flat sheets. Okay. They can be just randomly broken. Okay. Like this. All right. There could be no form to it. It could just break in all sorts of different ways. Hey, look, there's no structure with this one. It's just broken in different ways. But the way I like this one though, is because this breaks in flat sheets, which is pretty cool. Let's see if I can break a piece off here. for you. Do it in the camera. Here we go. I'm starting to. Let's see how it is. It breaks in flat sheets just like that. Okay, I dropped some on the computer. That's all right. Okay, so this is mica. Okay, and that's an example of a cleavage test. You would just see how it breaks. Does it break in right angles? Is there no set breakage depending on the chemical composition? And this is mica here. This is a nice picture of it. Luster, how shiny something is or how dull it is. Okay, we're going back to the pyrite. Pyrite is very shiny. Okay, you can see it has a glare to it, a nice shine. All right, as opposed to something like this, which there is no shine to it. It's kind of dull. And again, we would just look at a reference sheet, a reference chart, and we would be able to identify what type of mineral it is. And remember, minerals make up rocks. Okay. Here's a mineral. This is a stinky mineral, so I'm not gonna hold it too much. We could use color. This is one of the few minerals that is yellow. You can see it's yellow. Okay. This is sulfur. Okay. This is stuff they make stink bombs out of. It smells. It smells like rotten eggs. So even my fingers smell right now like rotten eggs. So I'm gonna rub it on some talc. Okay, remember what talc is. Talc is baby powder to make my hands smell a little bit better. And these are the different ways that we use different kinds of tests to identify minerals. Okay, so minerals make up rocks. It's like the bones of rocks. Okay, and then we can do a couple simple tests and look at a reference sheet, which will be provided for you to try to figure out what minerals are what. Okay, and that's what we do. All right. Bones, any questions? No? You want to test some minerals? All right, let's go test some minerals.